going to be our lecture video for November 11th and 12th. Let's get out those notes and go ahead and get started. Which inequality goes with the following words? I want you to really think about this. If in a just normal sentence I say I want less than something, how can I represent that with an inequality? Well, we do have a symbol that is called the less than symbol, and it looks like this. All right, but often in a conversation I would never say greater than. It's more likely I would say more than. I want more than 4 watermelons. All right, and the symbol for that is a greater than symbol. So alligator facing to the left. Now imagine I say I want at most 5 watermelons. What symbol is that going to be? So at most 5. So ask yourself, if somebody says they want at most 5, is 4 okay? Is 3 okay? Is 5 okay? So at most is a less than or equal to symbol, because 5 would be okay if I said I want at most 5, but also 4 would be okay and 3 would be okay, and those are all numbers less than or equal to 5. All right, then at least, if we think about that one, I want at least 7 grapes. If I get 7, I'm okay, but if I get 8, I'm okay. If I get 9, I'm okay. So any number greater than or equal to 7 in that case. All right, so this is good to keep track of, because this is how we talk about inequalities in our daily life. And I would keep a little copy of that in your notes. All right, our goal for today is to be able to solve multi-step inequalities and double check our answers. Why are we doing this? To solve inequalities in more complex situations and to be sure of our answers. Very important this year that we know how to double check our work, since I won't always be there to look over your shoulder and see if you're doing things correctly. All right, so copy this one down into your notes. Let's solve it, and then let's double check it. Okay, so solving with inequalities is just like solving equations. I want to use my normal steps, including moving constants away from the variable, getting rid of coefficients and divisors at the end. So I look at where the variable is and what's being done to it. It's being divided by 10 and then added by 8. And the plus 8 is the most outside operation. So I can get rid of that with a minus 8 on both sides. Now I've got k over 10 is less than negative 1. Inequality stays facing the same direction. All right, how do I get rid of a divide by 10? Well, I multiply by 10. Whatever I do to one side, I have to do to the other side. Now I've got k is less than negative 10. All right, my variable's isolated with the number on the other side. I can put a box around this. But now the question is, how do we double check our answer? Well, we can't just plug in negative 10, because that's not actually a solution. Negative 10 is not less than negative 10. So we want to pick a number that is actually less than negative 10, such as negative 11. Normally just move 1 or 2 units to the side of our boundary value, and then use that to double check. And it's important to do it this way so that we can tell if our inequality is facing the correct direction. That's the easiest place to make a mistake, is facing the inequality the wrong direction. All right, so I'm going to plug in k equals 11 and see if I get a true inequality. Negative 11 over 10 plus 8 is less than 7. This is negative 1.1 plus 8 is less than 7. Is 6.9 less than 7? 7 is a slightly bigger number, so this is facing the correct direction. We can put our double check. All right, another one. Let's solve this inequality. So constants on both sides. Let's move it away from the variable by adding 10 to both sides. This negative stays behind. I'm left with negative 10k is greater than negative 70. Now I got to get rid of that negative 10. It's multiplying the k, so I can divide both sides by negative 10. But this right here is our trigger to switch the direction of the inequality symbol. If we ever multiply or divide by a negative, we have to switch that symbol. So now we got the inequality k is less than 7. And we're going to see if we switch that correctly, because we're going to double check it right now. Let's think, what would be a good number to double check this inequality with? What's a number that's less than 7? Well, let's do 6. Just pick one less than 7. And let's check it with 6. Is negative 10 minus 10 times 6 greater than negative 80? Negative 10 minus 60 greater than negative 80. Negative 70 greater than negative 80. And my tablet just died. Give me 1 second. All right, is negative 70 greater than negative 80? Well, when you have two negatives, you want the inequality to face towards the smaller negative. You'd rather be $70 in debt than $80 in debt. So this is facing the right direction, and this does pass our double check. All right, two more. Copy this one down. Zoom in a little bit there. All right, so I've got some parentheses. That's the first thing I want to deal with. Let's distribute in that 7. And I get 49a plus 21 minus 5a is greater than or equal to negative 287. We'll combine like terms. The 49a and the negative 5a, they both have an a, so that makes them like terms. So they become a 44a. Just add those coefficients. Plus 21 is greater than or equal to negative 287. Move the constant away from the variable. No need to flip the inequality here. This is not a multiplication or division step. And so now I've got, let's see, what would that be? Negative 308. And now divide both sides by 44. And I'm going to need my calculator for that one. You should do the calculation along with me. Here we go. Negative 308 divided by 44 is exactly negative 7. All right, but I divided by a positive. The step here is positive. Even though this is negative up here, the step is positive, so no need to flip the inequality. We get a is greater than or equal to negative 7. All right, let's pick a number that's just greater than negative 7. Let's pick a equals negative 6 and make sure we get a true inequality. 7 times negative 6 plus 3 minus 5 times negative 6 is greater than or equal to negative 287. 7 times negative 42 plus 3. And then a negative 5 and negative 6 become a plus 30. It's greater than or equal to negative 287. 7 times negative 39 plus 30 is greater than or equal to negative 287. And 7 times 39, I can't do that one in my head. It is 273, so I make it negative because that's negative, so negative 273 plus 30 is greater than or equal to negative 287. And we get negative 243 is greater than or equal to negative 287. And just like we were talking about, when you have two negatives, you want the smaller of the negatives. All right, last one. Here we have to distribute twice, and then let's double check our answer. So distribute the negative 6 here. Remember the negative comes with. Distribute the 4 over here. On the left, I get negative 2 minus 6 plus 24n. Negative times a negative is a positive. It's greater than or equal to negative 8 minus 20n. All right, let's combine like terms. The negative 2 and the negative 6 can become a negative 8. Plus 24n is greater than or equal to negative 8 minus 20n. We want to move the smaller term. And I think we can do this. I think we're up for it. Let's move the constant at the same time. Let's add 8 to both sides. All right, so here the negative 8 and the 8 cancel out. The 24n and the 20n become a 44n. Greater than or equal to, here these cancel out and these cancel out, but we have to leave something, so we leave a 0 behind. Let's divide both sides by 44. And you get n is greater than or equal to 0. Let's double check with a number that's just greater than or equal to 0. Let's double check with n equals 1. So negative 2 minus 6 times 1 minus 4 times 1. Is that greater than or equal to 4 times negative 2 minus 5 times 1? All right, so we get negative 2 minus 6 times 1 minus 4 times 1 is just a 4. So 1 minus 4 is a negative 3. Greater than or equal to 4 times negative 2 minus 5. 5 times 1 is just a 5. All right, negative 2. Negative times a negative is a positive, so plus 18 is greater than or equal to 4 times a negative 7. Negative 2 plus 18 is a 16. Is that greater than or equal to a negative 28? Well, when you have a positive and a negative, you always want to be facing towards the positive. So that does check out. Okay. That was our last one for this video. I'll embed a few more here, and have a good rest of your day.